Paper 1, June 2018. I've got a reaction. Nitrogen and 3 moles of hydrogen makes 2 moles of NH3. Slightly different this question because it's given me the mole fraction, 0.8 of ammonia in the mixture. That means that 0.8 out of 1, 80%, 0.8 as a fraction, is ammonia. So the remainder, the nitrogen and the hydrogen, must be 0.2 as a fraction of 1 mole of the total mixture. Now they're in the amounts 1 mole to 3 moles. So if 0.2 of the mixture is nitrogen and hydrogen combined, and they're in a ratio 1 to 3, the nitrogen is 1 part out of a total of 4. So a quarter of 0.2 is 0.05, and 3/4 for the hydrogen, 3 parts out of 4, 3/4 of 0.2, 0.15. I've now got the mole fractions of each of them. To work out the partial pressure, take the mole fractions, the fraction out of a total of 1, and multiply by the total pressure. That's 150 kilopascal. The 550 Kelvin in the question, by the way, is a complete red herring. It's not needed at all. We multiply each of them by 150 and we get the partial pressures of each of them. 7.5 kilopascal, 22.5 kilopascal, 120 kilopascal. Give an expression for the equilibrium constant Kp for this reaction. Partial pressure of NH3 squared, because there's 2 in front of the NH3 in the equation. Partial pressure of N2 multiplied by the partial pressure of hydrogen to the power 3, because there's 3 in front of the H2 in the equation. Given a completely different set of data now, and you just asked to plug it in. Plug the numbers in, and it gives you 0.0029. They allow you up to 0.003. Not sure why. Usually give you a range of marks as a possible answer when you have to read from a graph or something like that. I don't know why they've given you a range this time. Anyway, units, kilopascal. So Kp equals kilopascal times kilopascal. 2 pressures on the top because it's partial pressure of NH3 squared. I've got a kilopascal on the bottom, and I've got 3 other kilopascals for the H2, partial pressure of H2 to the power 3. Got 2 kilopascals, 2 pressures on the top, 4 on the bottom, cancel top and bottom, end up with 2 kilopascal on the bottom, or kilopascal squared on the bottom. Take it to the top, kilopascal to the minus 2. The enthalpy change of the reaction is minus 92. Minus 92 means it's exothermic. State the effect, if any, of an increase in temperature on the value of Kp. If the reaction is exothermic, that means it gives out heat in the forward direction as it makes more ammonia. Increasing the temperature by Le Chatelier's principle will try to oppose this change and lower the temperature. So it won't give out more heat to the surroundings. That would increase the temperature of the surroundings. It wants to lower the temperature by shifting the position of equilibrium to the left-hand side. That means you make less ammonia, less product, and your Kp, which has got products on the top and reactants on the bottom, will decrease.